Hi folks, welcome to the lesson, Rationalising Surds. I really don't know why we bother with this in the maths curriculum, but I'll keep my personal opinions to myself and we're going to crack on and get this job done. To rationalise means to turn a number into one that can be written either as a fraction or a whole number. Rationalise means, think of ratio, we can write it as a ratio, so that's a fraction or a whole number. A surd is not rational, we call it irrational. Therefore, we want to turn the denominator, which is root 7, and root 7 is irrational, we want to make that rational. And the only way we can do that, if we look at the yellow box, is if we multiply root 7 by root 7. Actually, that's not quite the only way, it's the simplest way. Now, in order to keep the fraction the same value, we have to multiply by root 7 over root 7. Why? Because root 7 over root 7 is 1, and multiplying by 1 keeps the value the same. But the reason why we're doing this is because when we multiply two fractions together, we're going to end up multiplying these two denominators. And when we multiply root 7 by root 7, it becomes 7, which is rational. Job done. Therefore, the answer when we multiply these two fractions together is 1 times root 7, which is root 7, divided by root 7 times root 7, which is 7. And that is our final answer with the denominator turned into a rational. In our second example, can you think what might we need to multiply by in order for that denominator to not be irrational? It's root 5 over root 5. Remember, root 5 over root 5, that's 1. So we're not changing the value. And when we multiply these two fractions, the denominators get multiplied together, and that's going to make the denominator rational. So the numerator 2 times root 5 is 2 root 5, and the denominator root 5 times root 5 is just 5, which is rational. Here are two more examples. In part C, we focus on the root 5 in the denominator. We need to make that rational, and to do that we multiply by root 5 over root 5. Remember, root 5 over root 5 is 1, so we're not changing its value. And in the denominator, when we multiply these two fractions together, the two root 5s get multiplied together to make 5, because root 5 times root 5 is root 25, which is 5. So our numerator is 3 times root 5, and our denominator, root 5 times root 5 is 5, times by 2 is 10. In part D, first thing we need to do, let's simplify root 12. It can be simplified. We can write that as root 4 times root 3, which is 2 root 3. So now part D becomes 5 over 2 root 3, and we focus on that root 3. So we multiply top and bottom by root 3 over root 3, remembering that root 3 over root 3 is 1, so we're not changing the value. And when we multiply the two fractions, those two root 3's get multiplied together. That will make root 9, which is 3. So the numerator is 5 times root 3. The denominator, root 3 times root 3 is 3. And we're timesing that by 2 to make 6. Let's put this all together then in a recap. To rationalise means to turn a number into one that can be written either as a fraction or a whole number. A surd is not rational, we call it irrational. To rationalize a surd, you need to multiply it by itself. The square root of a multiplied by the square root of a becomes the square root of a squared, which is just a. If we have a fraction where the denominator is a surd, we rationalize by multiplying by root a over root a. Now let's see that in this example. In the denominator we've got root 7, so we multiply top and bottom by root 7. And we do that because root 7 divided by root 7 is 1, so we're not changing the value. And when we multiply two fractions, the two denominators get multiplied together, and root 7 times root 7 is root 49, which is 7. So it changes from being irrational to rational. So our final answer, the numerator is 1 times root 7, which is root 7, all divided by 7. So although the numerator is irrational, the denominator has become rational. And that's what we were trying to do. We were trying to rationalize the denominator. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.